So in this session, we are going to discuss least squares criteria for the least squares regression line. I'm using Wolfram Alpha's demonstration website to do this. So we are starting with data set 1, and we've got x and y values. There are 5 pairs of values, 5 blue dots you see, that's a data set. And the slope and intercept here are the slope and intercept of this regression line. And I would like you to focus on 2 things. One is the sums of squares number up at the top, and then look at these squares here. Okay, so for example, this blue dot is the data point, xy data point, and this little dash line represents the deviation or the difference between the actual y value and its fitted value. So the deviation between y and the y hat. Okay, so that is what we call residual or the error. Okay, and then this the red outline, that square, so we are actually squaring the residual. So the area of the square here represents the residual square. Okay, so the least squares criteria, what it does is it's determining the slope and the intercept of the regression line in such a way that sums of squares of residuals is minimized. Okay, so look at this, the sums of squares number. If I move the slope a little bit to the right, you see that the sums of squares have gone up significantly. You can visually see the squares. Okay, if I move to the left, again you see the sums of squares have gone up significantly. Okay, so now let me go back to the least squares line. Then now intercept, look at the sums of squares number. If I move the intercept a little bit to the right, you see sums of squares gone up. And if I move a little bit to the left, again it's gone up. Okay, so you can visually see that if I move the slope or the intercept to the right or left from the least square values, then you see that the sums of squares of residuals is increasing. So this is data set 2, and so look at the sums of squares. The points are very close to the line, so the sums of squares is very small, 0.77. If I increase the slope tiny little bit, immediately you see the sums of squares gone up significantly. If I move it a little bit to the left, again you see it's gone up significantly. And same thing, you can see the intercept, I move to the right and sums of squares gone up, and a little bit to the left, again it's gone up. Okay, and let's look at the data set 3. Again, look at the sums of squares number here up at the top, and then look at the squares. If I move the slope a little bit to the right, you see the sums of squares gone up. If a little bit to the left, again it's gone up. Let me move the intercept a little bit to the right, and you see sums of squares gone up. And a little bit to the left, again it's gone up. So you can see that visually the least squares line, that the slope and intercept or determined in such a way that sums of squares of residuals is minimized. Thank you.